Alright students, so in this lesson we are going to solve multi-step linear inequalities, and let us begin by solving this multi-step linear equation. So to solve for y, I have to get the y by itself, so I must get rid of any other term next to the variable term here. So let's add 5 to both sides, and I end up with 2y is equal to 12. The inverse of multiplication, we know it's division, so I divide by 2 on both sides, and y equals 6. So the solution to this equation, it's y equals 6. Now, when we look at inequalities, when we solve inequalities, you need to treat inequalities just as if you were solving equations. So for example, let's say we have 2y minus 5 is less than 7. In other words, 2 times a number minus 5 is less than 7. What number could that be? Well, let's treat it as an equal sign. Let's add 5 to both sides of this inequality, and I end up with 2y is less than 12. Well, divide by 2. Y is less than 6. This implies that any number less than 6 would be a solution to this inequality. So a number less than 6 could be 5, because 2 times 5, if I take 5, plug it in into y here, 2 times 5 is 10, minus 5 is 5, and 5 is less than 7. So anything less than 6 would satisfy this inequality here. So that would include 4, 3, 2, even negative numbers, negative 3, negative 4, and so on. So the only difference between equations and inequalities is just that, the equal sign and the inequality sign. So if I needed to graph this function, or this solution I should say, if I needed to graph this solution here, y is less than 6, I could do that. I could graph that answer on a number line. So I have 0, 1, 2, 3, 4, 5, 6. So y is less than 6. That means that the solution has to be less than 6. So it cannot be 6. It has to be less than 6. Could it be 5.9? Absolutely. So anything less than 6. And to imply that 6 is not a solution, we leave an open circle. This means that the solution is not 6, but it's something less than 6. Alright, let's do a few more. Let's do a few more like this, multi-step inequalities. The next one we're going to do is 2x minus 4 is greater than or equal to 4x minus 1. Well, same idea. You treat the inequality as if it was an equal sign just for a moment, and then you solve. Let's combine the x's, variables, and the constants. So what I could do here is I could subtract 2x on both sides, and that gives me negative 4 is greater than or equal to 2x minus 1. Then I can add 1 to both sides, and I get negative 3 is greater than or equal to 2x. Well, I'm almost there. I just have to divide by 2 on both sides. And I end up with x is less than or equal to negative 3 over 2. Negative 3 over 2. So I can write this solution, I can write it as x is less than or equal to negative 3 over 2. Notice these two inequalities are equivalent. On this one here, we have the constant first, and then we have the variable. On this one over here, we have the variable first. But if you look carefully at the inequalities, the inequality is pointing to the x, just like this one here. To graph something like this, we could go to the number line, and so this is 0, 1, 2, 3, -3, -1, -2. So this implies that x, or the solution, has to be less than or equal to -3 over 2. Now, -3 over 2 is just -1.5. So -1.5. And notice how this circle is closed. It's closed because x could be -1.5. X is less than or equal to 1.5. So we are going to leave this circle closed and say it could be -1.5 or anything less than that. Anything less than that. All right. A few words to consider when looking at story problems, and this is very critical. There's a few words that will tell you what inequality to utilize. The first one is greater than. Well, you guys know what that looks like. Greater than, less than, at most, so at most would be something like less than or equal to. You can also often see this phrase here, no more than. Alright, so all of these phrases here refer to this inequality. When we look at no less than, or at least, these refer to greater than or equal to. All right. Another one could be greater than, or equal to. All right, and all these three here refer to this inequality. So one example of a phrase where you have to translate from words into algebraic expressions could be, you must be at least 16 years of age to drive. So you must be at least 16 years of age to drive. Well, that's going to be something like this. Alright, at least 16 years of age to drive, which means you could be 17, you could be 18. Alright. Let's say you go to the store, and the most you can spend at the store is $20. You're going to buy apples and oranges, but the most you can spend is $20. So you're going to buy apples, oranges, and the most you can spend is $20. Let's say apples cost $3 a pound, and oranges cost $4 a pound. Well, let's come up with a variable for each. Let's say this is x, and this is y. So, $3 per pound of apples plus $4 a pound for oranges should be at most $20. So this would be an inequality that shows the word descriptions or the story problem. Keep that in mind, guys, because you will do a few story problems in your homework set. So this is going to help you with that. Play it as many times as you want to. Go back, rewind it. If you have any questions, do let me know.
Have a nice day.